there's a thunderstorm developing behind me, but right here where I am, it's relatively calm for now. What causes storms like these to develop? And how does the weather change so frequently? Let's find out together in this episode all about air masses and fronts. The weather changes every day. Some days are calm and sunny, and others are cloudy and filled with rain. If you live somewhere similar to my home here in North Texas, the weather can be dramatic and unpredictable, sometimes changing wildly throughout a single day. But what causes weather conditions to change? Weather is driven by complex interactions between heat energy from the sun, air pressure, temperature, and moisture. These interactions vary with the latitude, altitude, and local and regional geography. Earth's tilt, its rotation, and its distribution of land and water all affect the way that wind like this moves around the world. But where does the wind come from? Clearly, that direction. But that's not what I mean. The driving force behind wind is the pressure gradient force, or temperature and pressure differences. We usually don't think about the air around us as having mass when we're going about our day-to-day activities. It's usually clear and doesn't seem to have an effect on us unless the wind is blowing. The wind. It's windy. Except even when you don't feel the wind, the air is never totally still. The molecules of air surrounding us are moving and colliding with each other and everything else around them. Air does in fact have mass, and gravity pulls that air down toward the Earth. Gravity holds the atmosphere against the Earth's surface, like a cozy blanket, preventing it from drifting into space. At the Earth's surface, air is much denser and under higher pressure. It's being squished or compressed by the weight of the air above. As you travel to higher altitudes, air becomes thinner and lighter. Temperature also affects air pressure. Unequal heating of the Earth due to its curved shape and tilt cause areas of high and low pressure. Air here, near the equator, is heated more intensely by the energy of the sun, causing it to become less dense, so it rises. But here, near the poles, the sun's heat is less intense, causing cold, dense air to sink down toward the Earth. We can observe this action here. I have two containers. One is filled with hot water, and the other is filled with cold water. The air above the containers is either being heated or cooled by the water underneath. I have cut off the top and the bottom of a water bottle, so we just have a tube structure left. One end is dipped into some bubble solution, or you can use dish soap with a little bit of water. Let's observe how the hot and cold air interact with our bubble surface. The hot air is creating more pressure, causing the bubble to expand outward. And here, we see the cold air has less pressure, so the bubble is collapsing. So what does this mean for weather? These differences in pressure create wind. It's windy. Wind is simply the movement of air from areas of high pressure to areas of low pressure. Severe weather conditions, like this approaching storm, occur when pressure differences cause rapid air movement. A barometer like this one measures atmospheric pressure, or the weight of the atmosphere above us. It's used to predict weather changes. A fast drop means that a storm is incoming. A slow drop means that rain is coming. Stable means that there's no short-term change. And if it's rising, the weather is improving. Over the past 30 minutes, I've gotten these measurements at my current location. This storm is heading my way. There are two types of pressure systems: high pressure and low pressure. A high pressure system is sinking air, which warms and dries the local area, leading to fair, clear skies. Think of the sun high in the sky on a clear, perfect day. Some barometer measurements from today look like this. A low-pressure system is rising air that then cools, condenses, and creates clouds, rain, and stormy weather. Think low for lousy weather. Let's create high and low pressure systems inside of this bottle so we can see their characteristics in action. We're going to use isopropyl alcohol instead of water to speed up evaporation. Now I'm going to add some air pressure. This air compressor is going to force air inside of our plastic bottle, increasing the air pressure like a high pressure system. The bottle is clear under high pressure, But what happens if I rapidly decrease the pressure? We created a cloud. Inside of our bottle is a low pressure system. It's a lousy, cloudy, rainy day in there. A dramatic drop in air pressure inside the bottle allows the vapor to condense into rubbing alcohol particles and creates a cloud, just like water vapor condenses in the atmosphere and creates clouds. What will happen if we increase pressure again? Our cloud is gone. It's a clear, high-pressure, sunny day. Lousy. If you're still here, liking this video, let us know. And hit that subscribe button so you never miss an episode. The air that's over a warm and humid location like South Florida will begin to take on the characteristics of that area, creating an air mass. An air mass is a large volume of air that has roughly the same temperature and water vapor content or humidity throughout. Air masses can be enormous, covering hundreds or even thousands of square miles. For an air mass to form, the air must stay over an area long enough to pick up the characteristics of that area. Kind of like when you hang out with that one friend and you start to say their favorite phrases. Bruh. Air masses are always moving, and as air moves across new regions, they begin to pick up characteristics of that region and begin to change. What can I say? They're easily influenced. Air masses are classified by its source region's latitude. This tells us the temperature. And surface type. The surface type will either be continental, forming over the land, or continents, which creates dry air masses, or maritime, forming over the oceans, which creates humid or wet air masses. As we learned earlier, air near the equator is heated more intensely by the energy of the sun, and air near the poles is colder because the sun's heat is less intense. Air masses formed over the equator are called equatorial and are very hot. Then moving farther north, you have tropical air masses, which are warm, then polar air masses, which are cold, and lastly, Arctic air masses, which are the coldest. Air masses are named with a combination of their source regions, latitude, and surface type. Some common combinations are continental polar, maritime polar, continental tropical, and maritime tropical. Did the air mass form over the land or ocean? And did it form in a hot, warm, cold, or super cold area? As air masses move across the Earth, eventually they will collide, which sounds aggressive and kind of is, as far as weather goes. Fronts form at the boundaries between the air masses. A front is simply the point where different air masses meet, and they're labeled in reference to the temperature of the air that is approaching. A warm front occurs when a warm air mass overtakes an air mass of a colder temperature. This produces widespread clouds of precipitation along the front and just ahead of it, as the warm, humid air flows further up. If a cold, dry air mass pushes into a warm, humid air mass, then we have a cold front. Cold fronts will move across the ground and lift existing air at a very rapid rate. And this rapid upward motion will cool the air and form cumulus clouds. This typically produces very abrupt, sometimes very intense active weather. A stationary front occurs when two air masses meet, but neither one moves the other out of the way. Stationary fronts may produce long periods of precipitation before one of the air masses eventually pushes the other air mass out of the way. Occluded fronts form when a fast-moving cold front catches up to a slower-moving warm front. The more dense cold front will then lift up the warm front and eventually interact with whatever type of air mass was in front of the warm front before it got tossed up out of the way. This pile-up of fronts, so to speak, can create a variety of weather conditions, from dense fog to heavy rain. The resulting type of weather and its intensity varies wildly depending on the temperature and humidity differences of the colliding fronts. So the next time you're enjoying a nice sunny day due to a high pressure system, or bracing for an approaching storm, a lousy low pressure system, remember, weather is always changing. So if you're bummed with your current weather, just wait a bit and you'll get something new. And if you want to learn more science, you can check out this video next.
Weather changes every day.